Okay, this problem asks us to take the interval from 0 to 2 of f of x equals x plus 3. That's this straight line. And find the area under that curve using left and right hand or lower and upper Riemann sums by letting n approaches infinity. That's the number of rectangles. Okay, so by the way, you could do this with geometry. You don't need calculus because that figure is a trapezoid where this base is 3, this base is 5, and the height is 2. And the height times the average of the bases tells you that when we use Riemann sums, we should get an answer of 8. We're going to divide the interval from 0 to 2 into n equal subintervals. So that's b minus a, 2 minus 0 over n. So that represents the width of each rectangle. If there's 100 rectangles, then each width would be 1/50th. Okay, so for the lower sum, we've got to get a formula for these left-hand endpoints right here. In other words, here's a rectangle that has this height. That's the first rectangle right there. And then the second rectangle, I'll go to a different color, will have that height. And of course, that width, and so on until we've divided it into so many rectangles of equal width. All right, so we need a formula for these guys. The ith rectangle, or the ith left-hand endpoint. So if we start at the left hand, the first left-hand endpoint is 0. The second is we start at 0 and add on 1 width. That gives us 2 over n. For x sub 3, we start at 0 and add on 2 of these widths. And we get 4 over n. But the idea is to notice that x sub 3, that multiplier is 1 less than that. So x sub I is I minus 1 times 2 over n. Could write that a couple different ways, but there's one way to write a formula for x sub I. And the area of the ith rectangle is the width times f of that number. And f of that number just means put that number into the x plus 3 function. And if I distribute that, I get this. So there's a formula for the area of the ith rectangle when we have n rectangles. And now to approximate that area, we're going to take the sum from I equals 1 to n of that expression for the area of the ith rectangle. We're adding them all together. And I could continue carrying this down, but now we're going to use some properties of the summation symbol. I can kind of mentally visualize distributing it over each of these terms. And you can factor out a constant multiplier from a summation. So the sum of 4i over n squared is the same as 4 over n squared times the sum from I equals 1 to n of I. And I'll do the same for each of these. These are just constants. So I can factor them out. Whoops, this should be a 1, not an I. Okay, and so there's formulas for the sum from I equals 1 to n of I depending just on n, and this is it right here. N times n plus 1 over 2. The sum from I equals 1 to n of a constant is just n times the constant, so n times 1, that's this n. 6 over n times 1, that's this constant. Over here, these cancel out. One of these cancels out. And if I distribute this and picture canceling this 2 into this 4, I end up getting 2 times the quantity 1 plus 1 over n minus 4 over n plus 6. And you know what? I could have been carrying this symbol all the way along. Okay, so the true area is the limit of this expression as n approaches infinity. And as n approaches infinity, this term goes to 0, so does this term. So we have 2 times 1 plus 0 minus 0 plus 6 equals 8. Same result. If I go to board 2 and do a right-hand sum, it's a little bit easier because x sub 1 is just 0 plus 1 width. And we could do a couple of these to see the pattern, but the pattern is for the ith right-hand endpoint, it's I times 0 plus I times 2 over n, or 2I over n. So to find the area of the ith rectangle, it's the width times f of this x sub I. But how do you find f of that x sub I? You plug it into the x+3 formula, kind of distribute that, you get 4i over n squared plus 6 over n. And now that's a sub I. We want to add up all of those rectangles. So the area approximate the sum from I equals 1 to n of a sub I. Again, properties of summation symbol, 4 over n squared plus factor out the 6 over n. You get 4 over n squared. There's the replacement. There's the replacement. N times 1. This becomes a 6. This becomes 2 times 1 plus 1 over n. Oh, and I could have been carrying this limit as n approaches infinity the whole time. But I put it at the end. So a equals, as n approaches infinity, this term goes to 0. 2 times 1 plus 0 plus 6 equals 8. Same result. Okay. There you go. Hope that helped. If you have any questions, post a comment.